Hello everyone, in this lecture we will be starting a new topic, that is unit number 4, machine tools. So in the workshop practicals we had a discussion with the all machines parts, their basic function and the few operations performed on different machines. So here unit number 4 consists of different machines after manufacturing process, how different operations can be performed. This we are going to discuss. So here we'll be discussing three major machines and their operations. So lathe machine, second drilling machine, and the third grinding principle. So that is, we can say the grinding machines are not part of syllabus, but we are discussing grinding operations. So lathe machine, that's universal machine, drilling machine, and the grinding operations. So we will start what is machine tools. So basic functions are explained, which we had in discussion with unit number 1. So first, functions hold, support and the guide of different machine tools. So here in lathe machine we know the workpiece is placed between the chuck, or it is clamped by the chuck and it is rotated. The cutting tool, which is consist of hard material, which cuts the soft material off as workpiece. Then it provides a motion to the workpiece or cutting tool or both of them. So we know that in case of lathe machine, the workpiece is placed or it is clamped in a chuck which is rotating, whereas for drilling machine the workpiece is clamped on the work table and the drill bit is moving, it is rotating. The third one is as a function. It control or regulate the cutting speed and the feed between the workpiece and cutting tool. So we'll discuss all these things with diagram. The machine tools are again classified as metal cutting machine tools and surface finishing machine tools, out of which, as discussed, we have a syllabus of three parts: lathe machine, drilling machine, and in the second type surface finishing, grinding machine principles or operations. Milling machine and shaping machine not in the syllabus, but for general knowledge it is placed here. A different machine tools or metal cutting machines are milling and shaping, whereas surface finishing machine tools are grinding. These second, third and fourth surface finishing machine tools are not in the syllabus. It is just to know different grinding or surface finishing operation as honing, polishing and the lapping process. So we'll start with the first part of unit number 4, that is lathe machine, called as a center lathe or universal machine. It is the machine tool used for removing the undesirable material, so we can say the metal cutting operations, in the form of chips from cylindrical surface. So we here in case of lathe machine we use a cylindrical workpiece and the material is removed in the form of chips. The cutting tool is a harder material, that is a carbide material is used as a cutting tool material. So of course the workpiece materials are MS as very common material, mild steel, low carbon steel. Carbide or tungsten carbides are common cutting tool materials. These all points are important to remember for MCQ. So a simple block diagram of a lathe machine, which consists of different parts. So we will just discuss the function. This diagram is actually a screenshot of one diagram which consists of a block diagram plus the function of every part. So here I'll just focus with the function and the part name. Let us say we'll start with part number 1, that is lathe bed. This lathe bed is used for as a support member. So its function is to support all other elements of lathe, because on this bed whole machine is standing. So it is like similar to our leg. So I can say this function is to support all elements of lathe machine. Then second element very important is headstock. It is also called as live center. So headstock function is to support the spindle. This is spindle. The function of headstock is to support the spindle and to house main drive. Third part is opposite to this, that is tailstock. This is headstock and this is line, that is this part tailstock. This also called as dead center. The basic function of tailstock is this whole assembly as a tailstock. The basic function is to hold the dead center. So here we can place a drill bit and we can do the drilling operation. So it, as mentioned, function to hold the dead centers and to hold the tools like a drill, reamer. So we can do the drilling operation, reaming operation on the lathe. We can put this cutting tool here, that is in tailstock. Another function, if we have a long cylindrical object, so it may vibrate during motion. So by using this dead center, we can provide the support to this cylindrical object. Next one is this 4. Whole object can be called as carriage. This whole structure can be called as a carriage. Again, this carriage consists of different parts. We'll see the function. To hold the cutting tool, that is a basic function of this part called as a tool post. So the function of tool post is to hold the cutting tool. Then here we have these two wheels, larger wheel, one smaller wheel. This larger wheel provides motion to the carriage in this direction, that is longitudinal movement parallel to the axis of workpiece. And the smaller wheel provides the cross feed. So hence the name it is given cross slide. Then we have this small part called as compound rest. It is used to give some angle which is used for taper turning operation. This part is chuck. 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 The function of the chuck is to hold the workpiece. So I can place workpiece here, which can be clamped by using this chuck. Next part is here, as mentioned, lead screw. The function of lead screw is to provide a mechanized motion to the carriage. So the carriage is moving here. So it provides mechanized motion to the carriage. Next part is feed drive. This one. It transmits the power from main drive to the lead screw. So from drive to this lead screw, it transmits the power. So that is fed drive. So these are a few major parts of lathe machine which is required for MCQ point to understand the function of each element of lathe machine. So general part as summary, leg or it is bed, lathe bed, supporting member of whole machine, headstock, live center, tailstock as a dead center. Very important heart or the important system is carriage, which consists of saddle, that larger wheel, smaller wheel is a cross slide, compound rest and tool post. Chuck, the function of the chuck is to hold workpiece and the function of tool post to hold cutting tool. As it is a center lathe, center of live and dead center, that is headstock and tailstock, they should lie in the same plane. So these are the functions summarized here. So where again we'll discuss the functions slide after the operation slide. Next, the specification of lathe machine. So if you want to purchase a lathe machine, what are the different parameters that you should ask? So that are the specifications. So normally here we'll discuss basic parts are explained here with the previous diagram and the functions they are summarized starting from 1 to 5 part of the carriage. So here the first part of the carriage here as apron, this first part, Now here we are discussing only the carriage exaggerated view. So the carriage first part is apron. As mentioned, you can see here the motion parallel to the axis. Second is the saddle, this wheel, larger wheel, which we have seen in the previous figure, that saddle, which slides along the guideways of lathe bed. Here we have this lathe bed, which slides on the bed. Cross slide having a cross motion, that is, it provides a feed to the cutting tool. Compound rest, this one is compound rest. Third one, it is mounted on the cross slide and used for taper turning operation. That you should remember, we are using compound rest to give a tilt which is required for taper turning operation. And the last one, uppermost part of the carriage is tool post, where cutting tool is placed to hold the cutting tool for different operations. This is the basic thing. Now next slide we'll discuss about different lathe machine operations. So let's go and discuss this part as specification of lathe. So the lathe machines are specified with four different parameters. First is overall length of lathe machine, that we call as overall length of bed. Second is distance between the centers, that is distance between the live center and dead center. Second point. Third one is a swing, where swing is the maximum diameter of workpiece that can be machined. So that actually swing indicates, let us say swing is, if it is 15 millimeter, that indicates the 15 millimeter is the maximum diameter that we can machine on this particular machine, lathe machine. And the last important, minimum and maximum spindle speed, that we can see the spindle range, the speed limit for spindle. So these four parameters are important to remember for specification. Now different operations of lathe we'll discuss one by one. As summarized here, 12 operations: turning, different types of turning; second, facing operation; then again grooving, parting in the same category, slight difference; knurling is again not metal cutting operation; and then the rest of the parts are some basics for drilling operation. So yes, we go with basics. First, turning operation, it is also referred as straight turning, or sometimes if there is a step turning. So here we use a single point cutting tool. You can observe here a goldish color cutting point is used as a single point cutting tool, which is as a cutting tool for turning operation and facing operation. Then the motion parallel to the workpiece axis in this operation for turning, with the schematic diagram you can understand. For the turning operation, we are reducing the diameter and the cutting tool moves along the length of workpiece. So the motion of the cutting tool is longitudinal. It's a parallel to the workpiece and spindle axis. How we can define turning is the process of removing the material from cylindrical workpiece to reduce diameter. So that's very common sentence, process of removing workpiece material, that is of course logical cylindrical workpiece. What is function? To reduce diameter. So if it is a constant change in diameter, that's straight turning. Next, eccentric turning, again slight change with the basic functions of turning operation. Here again we use a single point cutting tool. Everything is same. The difference is motion of cutting tool is again parallel longitudinal. In case of the eccentric turning operation, the about two separate axes or rotations of workpiece are used. So here you can observe the axis of workpiece and the axis of forge or chuck, that is we can say the machine axis, it is different. There is an eccentric difference between the two axes, that of course that is possible only when we have forge or chuck. So for eccentric turning, when the axis is not constant, not same, not collinear, we use forge or chuck to have two different axes for workpiece as well as jaw, or that is for machine. Next, another type of turning is taper turning. When we want to reduce the diameter not with constant rate, not constant value from 40 mm to 30 mm along the constant length. When we want to reduce diameter gradually, uniformly along its length, then that operation is called as taper turning. So movement of cutting tool is in the taper direction. We use a compound rest here. Then at what angle we need to rotate the compound rest, that can be found by using this formula. Tan alpha is equal to d minus d upon 2l, whereas capital D is, let's say, 40 mm, small d is, let's say, 30 mm, and 2l, that l is the length of workpiece. So from highest diameter to the lowest diameter across the length, we can have this formula alpha. With this angle we have to change or rotate the compound rest. Second operation, facing. Facing is completely opposite to the turning. Again here we are using single point cutting tool. The motion is perpendicular to the axis of workpiece and the spindle, which is given by using cross slide, that is a cross motion. Definition again same. Process of removing the material workpiece at end surface, that is at the face, to produce flat surface. So very simple, along the face material is removed, that is facing operation. Next, grooving operation. For grooving, the multi-point cutting tool is used to create a groove on cylindrical object. The motion of the cutting tool is perpendicular to the spindle axis, that is by using cross slide. Here the required shape is formed or reproduced on the workpiece by using multi-point cutting tool, that is grooving tool. So you can observe different diagrams and this multi-point cutting tool to provide a groove, to create a groove on cylindrical workpiece. Parting operation. Parting is similar to the grooving, where again we have multi-point cutting tool for parting operation. The motion again here is perpendicular to the spindle axis and it's given by using cross slide. Definition of parting is it's cutting the workpiece in two parts. So we are parting the workpiece. So cutting the workpiece in two parts, that's we can say parting, and that's the difference between parting and grooving. Grooving is creating a small groove inside a cylindrical workpiece. Next, very important operation which you might have seen a lot of application in day-to-day life, that is knurling. So basically knurling is not metal cutting operation. In all previous operation we cut some part of workpiece. Here knurling tool is a multi-point cutting tool where the some patterns are embossed on the workpiece. Again the motion is cutting tool movement, that is a knurling tool movement is parallel longitudinal to the axis and the shape is embossed by using cross slide. The here diamond pattern, regular pattern is impressed in case of embossing operation. And why it is doing all this operation? To provide non-slip grip and to reduce or to provide a proper friction when you are handling any components. So sometimes it gives aesthetics appearance, that means a decorative look to the workpiece, as well as it provide non-slip grip to the surface. So this is actual 3D diagram of knurling tool and schematic sketch. The feed direction and the depth is given. So feed is as the movement of cutting tool is parallel and the depth is given by using cross slide. If the workpiece is large, we can provide the support by using tailstop. Next operation is chamfering. For it is again a multi-point cutting tool similar where we need to chamfer the edges. Again the why we are using the chamfering operation is because to avoid injuries and to enhance the look. So many times to avoid injury to the cylindrical and the sharp corner workpieces, we do the chamfering operation by using multi-point cutting tool. The motion is again same. The feed is a cross feed to chamfer the edges. Next, drilling operation on lathe machine. So we can do the drilling operation, create a cylindrical hole in lathe machine possible, where we need to place a drill bit, twist drill bit inside a tailstock dead center, which can be placed to create a hole in cylindrical objects. The motion in case of drilling operations is by using tailstock. So here you can observe in this diagram, a drill bit is given a feed, whereas workpiece is rotating, which is placed inside the chuck. We can do the reaming operation, drilling operation, and few operations similar to the drilling machine. So that's the difference between drilling operation on drilling and lathe machine. For lathe machine, workpiece is rotating and the drill bit is given feed by using tailstock. Whereas for drilling machine, drill bit is rotating inside the spindle and chuck while workpiece is stationary. So you should remember that is the difference between drilling operation on these two different machines. Same operation, reaming operation, it is used for cleaning and smooth out the surface of already drilled hole. So reaming is multi-point cutting tool. This drilling is also multi-point cutting tool. So this is what all the operations on drilling machines. Means we can do the reaming operation and drilling operation on drilling machine, but these two operation can be performed on lathe machine. So that's a different operations performed on lathe machine. In next lecture we'll discuss with another types, that is drilling machine and their operations.